Hi everyone, and welcome back to the lab. In this video I'll be making one of the most useful copper compounds there are on the planet, in my opinion, and that is basic copper carbonate. It's this formula over here, this wonderful compound. It's just copper carbonate, but it's got a couple of hydroxyls coordinated to it. That's just how copper compounds are. I'll get into that in future videos, but anyway, it's useful because you can make many other copper compounds from it. It's a highly insoluble compound, so it's easy to make, and when you react it with acids, in this case I've reacted it with hydrochloric acid, you end up with carbon dioxide, which goes away as a gas, of course, water, your solution's already made of water, and copper 2 chloride. So you have very pure copper 2 chloride as long as you've added enough acid to react all of this. So you can make all sorts of other copper compounds, not limited to copper 2 chloride here, nitrate, sulfate, whatever you want. Anyway, to make it is pretty easy. You just need a soluble copper 2 salt and a carbonate, a soluble carbonate salt as well. So, or you can use bicarbonate actually, I'll get into that. I'm going to use copper 2 sulfate. It's a cheap salt for me. You can use copper chloride or whatever you want. Really, any acid salt of copper, not a problem here. Sodium carbonate I'm going to use because it's cheaply available as pool pH up. It's designed to basify your pool. It's sold in bulk, really cheap, not a problem for this reaction, works great, and it produces only one CO2 on this side. If you use bicarbonate here, which works, I would say equally well, you end up with 2 CO2s on this side of the reaction once the whole thing is balanced, and that creates problems with foaming. And so you have to add it a little more carefully. It can be done, but not my preferred method. Anyway, this copper 2 carbonate here, it's basic copper carbonate I should say, is quite insoluble in water, and so it will precipitate as a light blue precipitate which will be filtered from the water, and then we can dry it and store it for future use. Anyway, that's about the gist of this video. Let's get to the lab and do it. The first thing to do, of course, is to weigh out the reactants, and then we'll get them dissolved in water. So I have here 256 grams of copper sulfate pentahydrate in the form of some nice thick blue crystals. And I also have 96 grams of anhydrous sodium carbonate. That's sort of just a white granular powder. I'm going to dissolve the copper sulfate in 700 milliliters, roughly, of hot water. And I'm going to dissolve the sodium carbonate in roughly 200 milliliters of equally warm water. And these will need some significant stirring and heating to get all of this in solution. So I will essentially get these stirring and then put them in the microwave and stir some more until they're both dissolved. I assure you they will go into solution. So sit tight while I go do that. Nearly there. I now have just about all the copper sulfate dissolved, forming this nice dark blue solution. However, my sodium carbonate isn't looking so good. You can see there aren't many solids left, but there is this milky suspension that's formed. That's typical for this type of sodium carbonate. There may be some calcium impurities in it which cause it to not fully dissolve. So I'm going to go ahead and filter this really fast through a vacuum filter. You can use a coffee filter or something if yours looks like this, but that's simply a consequence of using technical grade reagents. You can also see there's a piece of dirt floating in it right there. And since our final product is, we're going to filter our final product from the reaction mixture, all this stuff will end up in there if we don't filter it out now. I've set up here for vacuum filtration, although, like I said, you could use a coffee filter or something like that. And we're just going to run this through a medium frit and see what happens. Get the vacuum started. Apologize about the noise. There we go. And you can see it's a little foggy, so I'm going to run it through a second time, and hopefully that will eliminate the fog there. You can see we've captured some interesting things. Alright, just a little hazy. Okay, I think that's about the best we're going to do. Turn off the vacuum. So you can see it's still a little hazy, but that's not a big deal because the basic copper 2 carbonate that we're going to filter from the solution has bigger particle size than this, because we'll be able to catch that on a filter, and this will go right through it. So now that we've got our reactants dissolved and prepared, it's time to conduct the reaction. I'm going to use this 2 liter beaker here because this is quite a big reaction. I'll first pour the copper sulfate solution into this beaker. Great color. There we go. And then finally, the sodium carbonate solution, which should immediately start to precipitate the basic copper 2 carbonate, as well as give off a little bit of CO2. And there we go. You can see it's sort of chunked up. Let's give her a stir. We're now getting a little CO2. Just keep stirring to control that foam. This reaction will theoretically make 100 grams of basic copper 2 carbonate, which is this toothpaste sort of color that's forming here. And I'll just give this approximately 20 minutes to finish reacting while watching the foam. It'll slowly subside over time, and then we can go ahead and isolate the basic copper 2 carbonate. The mixture has now been sitting overnight. I had to go because of timing constraints, and you can see it's sort of a thick teal mixture now. And what that is a fine suspension of basic copper carbonate and a bunch of water, and then some excess of the reagents that we added, because of course you can't measure them out perfectly molecule to molecule. So what we're going to do is go ahead and vacuum filter this to get the basic copper carbonate out. So this here is the apparatus. This is my largest filter funnel. It's got a porous glass frit on there, right? Used one of these earlier, just a smaller version. Unfortunately, this is the biggest jointed Erlenmeyer that I have, so I'm going to have to empty this repeatedly during this process, but that's not really a big deal. So let's get the vacuum started, and again I apologize for the noise that this may make, and let's get going. Once each batch has become mostly dry, wash it with about 100 milliliters of warm water to dissolve out any of the leftover sodium carbonate or copper sulfate. That's done by pouring it in all at once, followed by agitation, and then just pull the water out of it again. After each vacuum filtration is complete, I scrape the paste out of the filter funnel and place it into a suitable glass drying pan. Just like that. And then we're ready for the next batch. I can just go right down the sink. There's nothing particularly dangerous in it. I'm going to rinse the beaker down with a little hot water as well. Alright, and this is the very last batch. So, because this is on such a large scale, it's a little bit to get through, but bear with me. And soon we will have this dried and stored. So you may be familiar with this method. I used it in the nickel oxalate preparation here. We're just going to take this pasty mix here and put it on a hot water bath, which will accelerate the drying of this by quite a lot. And by the end of the evening, I should have some dry powder. As a side note, when you're cleaning all this up, you can see this frit has been quite badly stained by the basic copper carbonate, but it is very reactive toward acids to form soluble copper salts, right? It's the reason we made this in the first place. So all you have to do is run any common acid through here that has a soluble copper salt, and that clears right up. So I've been soaking my equipment in this jar here, which has a little bit of hydrochloric acid in it, and this is getting the stir bar and all the equipment that I used clean. And so I'll just pour that in here, and we should pretty easily be able to clean this filter. You can see the fizzing happening in there. That's carbon dioxide, of course. And the discoloration is almost gone at this point. I'll pull this through just to get it into the frit. Some more. And this is going to serve to clean everything else, the joint, the beaker below, the funnel, everything. Alright, so I've spread this out on the glass pan, as mentioned before, about as evenly as possible, and I've got it on top of a steaming water bath here. It's not quite boiling, it's just set to simmer. It's just an electric pot, and this should get this stuff dry in no time. So I'll leave this for a couple of hours, and we'll come by and stir it every so often. That should be about it. Okay, it's been a few hours, and you can see it's still very pasty, but it's also quite warm, and you'll see it starts to change to this green kind of color. It's losing hydration water. So as it does that, it goes through several weird stages where you'll have this blue, highly hydrated form, and this green, sort of less hydrated form, and as that water leaves, it goes into the mixture and makes it a much more runny type of paste here. But we're going to keep drying it, and come back in a few hours when it starts to get clumpy, and we can turn it into a powder. Alright, so I left this on the water bath overnight, and it looks like this now, sort of like a dry lake bed, and that's because you can see it's pretty much dry and crumbly. So all I'm going to do now is just scrape this off the pan, and then I'll grind it up, pulverize it into a fine powder using the bottom of a beaker, because these are really, really brittle pieces here. And once it's all crunched up, it'll be ready to store in a container for future use. And here's the final product, a fine free-flowing teal powder of basic copper 2 carbonate. I'll be using this in a number of upcoming videos to make other copper compounds with, so if you'd like to see those or be notified when I make them, please press the subscribe button. If you liked what you saw or you found it helpful, please press the like button, and you can always leave me a comment as well, and I'll try and get back to as many as I possibly can. As always, thanks for watching.